is equal to root of, so it's positive, E square plus M square, and this P mu is simply, they are not all independent. So one component is EP, another is simply this. Okay, it's not P naught. P naught is here EP. Clear? Got it? So this is the Fourier decomposition what we had done yesterday. So now let's calculate this conjugate momentum. So this is an operator. Huh? So A's are A and A dagger, they are operators, and we need to figure out what is the interpretation of this A and A dagger. For the time being, so we will first figure out what is the canonical conjugate momentum, then we will figure out the Hamiltonian. Okay, from Hamiltonian we will get the interpretation of these A's and A daggers. Clear? So this is our roadmap. Okay, so let's calculate this phi of x. So what is phi of x? So it is simply phi dot for scalar field. So what is that? Partial by partial t of this phi of x. Okay. So now let's make a differentiation of this thing. So where is the time dependence? E raised for I. Okay. So e raised for minus I p dot x. So what is this thing? So let me write. So you are having integral. Let me write it for you people. Other you will do yourself. Okay. So let me know. Okay. So let's write it like this. So EP, then you are having this A of P. So what is your this exponential? Okay. So it's e raised for minus I p dot x. So this I can write e raised for I. Okay. EPT minus vector p dot x. Clear? So this is how you are having this p dot x. This is a 4 momentum and it's a 4 vector. Clear? So you define it. Now make a differentiation with respect to time. Partial by partial t. So only it will act on these exponentials. Okay. So let's make the differentiation. Minus I EP will come down. Clear? So you are having simply minus I EP, it will come down, and exponential will remain as such. Minus I p dot x. Now plus, then you are having this A dagger of P. So you are having I p dot x. Clear? So that means it is plus here. Huh? So you will get I EP e raised power I p dot x. Clear? So this is your this pi of x. Okay? Or you can now rewrite it like this way. Or your pi of x is simply equal to take I out, or minus I will take out. So it is d3p divided by root of 2 pi q. Okay? Root of EP. Okay, so it is like this way. Root of EP by 2 pi cube 2. Clear? So EP and EP, so it is root, so it is the root is upper, so it is P e raised for minus I p dot x minus A dagger of P e raised for I p dot x. Okay, so now what we'll do, so let's call this as equation 1 and equation 2. Clear? So now I want to solve these two equations. So I know phi, is it? So what is the commutation relation between phi and pi? So I am having this very commutation, equal time commutation, is it? So this is I delta 3 x minus y. So this is the equal time commutation relation. Clear? Now I want to figure out what is, since A and A dagger, these are the operators, okay? I want to figure out what is the commutation rule for A and A dagger. For that matter, what I require, I need to solve equation 1 and 2 for A and A dagger in terms of phi and pi. In other words, I want to calculate what is A in terms of phi and pi, and what is A dagger in terms of phi and pi. So this I need to know. But if you see, since this is a Fourier transform and it contains both modes or both kinds of momentas, so you are having positive momentum and the negative momentum here. Clear? So you are having two, left moving wave and the right moving wave. Clear? So you are having these two are there. So, and this is a Fourier sum. So I need a trick to get rid of this integration and this exponential here. If you see, it is actually essentially a sum of some f of k e raised for ik. Okay, and I need to get rid of some Okay, to get A in terms of this phi. Clear? Okay, how to do that? Okay, for that matter, what I will do, okay, so I will first derive an identity. So let me write this thing, fp of x. So let's define this object. It is a plane wave. So let's calculate the orthonormality condition of the plane waves. Okay?
Yes.
So fp of x I will write as 1 divided by root of 2 pi cube twice ep e raised power minus I p dot x. Clear? P is a form vector here. Huh? So is this a plane wave? Because it's an exponential e raised power ix, so it represents a plane wave. Clear? So now let's calculate. Okay, so the orthonormality condition of these plane waves. Okay, so one more operator I will define. Okay, so I define an operator. Let's say partial mu a, and let's say a b. So like this thing. So it's a bidirectional derivative. Okay, so let me define it. How it is defined as? So it is defined as a partial mu acting on now b minus partial mu acting on a b. Clear? So this is how we define this kind of derivative. Okay? Got it? So this is the definition. So this is how we define it. So you act this on b multiply a. It is not the product rule. You are having a minus here. Just remember, you are having a minus. Clear? Okay. So let's do it now. Okay. So this result I require. Okay. So let's rewrite it later on. So let's do it. Let's calculate that very thing. So let me take this very integral d3 of x. Okay. fp x. Okay. Then partial 0 like this thing. That means only the time derivative. fp prime of x. P and p prime are different. Clear? So let's evaluate this kind of integral and check what is the value of this integral. Okay. So let's check it. So what it will be equal to d3 of x. Okay. Now tell me. So fp of x. So you are having partial by partial t fp prime of x minus partial by partial t fp of x. Okay. Then fp prime of x. Okay. So this will define. Okay. Usually in quantum mechanics, when you do the orthonormality condition, how you do it? So psi p prime is equal to delta pp prime, is it? So, but it is you have to be a little bit extra careful here. So we need to invoke this kind of operation here. Now you will see it. Okay. So what is your fp? Just take a look. So 1 divided by, okay, just tell me, 2 pi cube twice EdB, is it? Then you are having partial by partial t of that. Okay, since there is, okay, so let me write it for you people. 1 divided by root of 2 pi cube, okay, twice EP prime now, because you are having a prime. E raised for minus I P prime, P prime dot x. Clear?
E raised first EP, FP.
Yes. So E raised power minus I. Sorry, I should take a star. I will take a star here. I'm sorry. So let's take a star here. Star. So you are having star conjugate. So I P dot x. Got it? So I'm taking the star. Okay. F star and F. Okay. So then you are having minus 1 divided by root of 2 pi cube, okay, twice EP, so partial by partial t, e raised for I p dot x, okay, so this is the one term, multiplied by e raised power minus I p prime dot x divided by root of 2 pi cube, okay, twice EP prime. Clear? So now let's differentiate this with respect to time. What I will get? Anybody? Okay. So I will get minus I
EP prime.
EP prime. Clear?
Yes.
Okay. So I will get like this thing, integral d3 of x. So e raised for I p dot x, e raised for minus I p prime dot x, and I will get from the derivative minus I ep prime divided by 2 pi cube, okay, twice root of ep prime minus, so what you will get here? I, so you will get simply I ep, then e raised for I p dot x, e raised for minus I p prime dot x divided by 2 pi cube, okay, 2 root of ep prime. Clear? Got it? Okay. So now let's look at this. Okay. So let's look at, since these two objects contain x, is it?
शायद प्लस आएगा बीच में.
No, y plus.
Because derivative minus IP.
So it is simply I
और
p.
सर ठीक है सर.
Okay.
Yeah.
It is I e p. Okay. So what you will get? You take all, since there is an integration over only x. Clear?
Yes, sir.
There is integration only over x. Okay. So what I will do? So you have this kind of integration, d3 of x, e raised for I p minus p prime dot x. Clear? Okay. So in the first term, what are the factors here? Minus I e p prime divided by, okay, so you take these factors out, okay, and the other term is, so now let's write it here. So let's write it I e p prime divided by 2 pi cube, okay, twice root of ep prime, let's write it, minus, then you are having integral d3 of x, so it is a minus I, yeah? So minus I. Okay, then you are having I d3 of x, e raised for I p minus p prime dot x divided by, okay, then you are having ep 2 pi cube, okay, twice root of ep prime. Now look at this very integral. So this is simply equal to 2 pi cube, okay, since it's a 3-dimensional integral, it's a representation of the 3-dimensional Dirac delta function. Clear? So it's simply delta 3 of p minus p prime. So this objective, so you are having d3 of x, e raised for I p minus p prime dot x, okay, sorry, I should write it in this way. Okay, so let me rewrite it. Let me rewrite this very integral. So let's call this as equation 3rd. Let's rewrite this thing. So this is d3 of x, e raised for I. You have to be very careful because these are 4 vectors, and the integration is over only the special coordinate. So you can write it as d3 of x, e raised for I, ep minus ep prime t, okay, minus then p vector minus p prime vector dot of x vector. Clear? So this exponential, time exponential will come out, e raised for I ep minus ep prime t integral d3 of x, e raised for minus I, okay, p minus p prime dot of x vector. So this object is equal to 2 pi cube delta 3 vector p minus p prime. Clear? Okay, so now you are having a function f of x multiplied by the delta function, is it? So what is that? So that is simply function evaluated at the point. So when p is equal to p prime, so ep will be same as ep prime, so it is 0. So that means this will give simply you 2 pi cube delta 3 p minus p prime. Clear? Because ep will be same as ep prime. So samajh aa? Now if it would have been, let's say, p plus p prime here, let's say, okay, if it would have been, okay, let's say if it is plus here and p is equal to p prime, then it will be twice iep here. Okay, got it? So what is the formula we have used? Okay, f of x delta of x, that is equal to f of 0 delta of x. Clear? So this is the formula we have used. Okay, so now let's look at this very thing. So you'll get 2 pi cube delta, 2 pi cube will cancel, and there is 2. EP and EP prime will be same. It is EP square. So you will be having what? EP by EP square. It's 1 by EP. Huh? No, sorry. It is 1. Huh? It will be minus I. What you are getting here? So minus I by 2. Similarly, you will be getting minus I by 2 here, and a delta function. So that means this equation third will be simply equal to minus I delta 3 P minus P prime. Clear? So just substitute this result here. So it will force P prime to be same as P. So it will be simply EP square here. Eh? So root and square goes, it will cancel out. What remains here? Minus I by 2. Similarly here, EP cancels. 2 by Q will cancel. It will be minus I by 2. And there is a delta function as well. Eh? So delta. So half and half, that will be 1. Clear? So in other words, this object. Okay? Okay. So this object is equal to what? Minus I. So I will take I on this side. It is delta 3 P minus P. So this is a very important identity. Huh? Clear? Now show that. Okay. So this will be the exercise for you people. So home assignment is, so show that this g3 of x, fp of x, I partial 0, okay, fp of x, fp prime, so that's equal to 0, and g3 fp star of x, okay, I partial 0, fp prime star. When both are stars or both are unstarred, so it is equal to 0. When one is starred and another is unstarred, it is equal to delta function. Whether you put a star here or star here, it will be delta function always. Clear? समझ आवा? Any question? Okay. So now let's move to the okay. So our phi is equal to. So I will write now phi in terms of this f. So it is equal to d3p by, okay, so since I am writing it in terms of f, so it is simply fp of x, okay, then p of p plus f star p of x a dagger of p. Clear? So this is how we can write now what? Phi, okay, in terms of f. Now what I need to do? So I need to make that kind of operation. Let's say I have to write a of p. So I will multiply it, okay, I will operate by this partial 0 in addition to, okay, so with this thing, so this kind of operation and integrate over x, clear? So what you will get? Ultimately a delta function, like this thing. Now look here. So what I will do, you are having already fp here, is it? So that means I require fp star, so I will write like this thing, fp prime star of x, then I partial 0 like this thing, acting on this phi of x. So and integrate over volume. Clear? So what that will be equal to? So it is simply equal to d3p. Okay. So you are having this operation. So it is fp prime star x. Okay. I partial 0. Then you are having fp of x and a of p, because this does not contain any time dependence a. Okay. So that is why this will not act on A. Then you are having plus fp prime star of x, I partial 0, okay, fp star of x, a dagger. Clear? So this is a kind of operation, and there is an integration over x. So let's write integration over d3p and integration over x. Clear? Everybody got it? Huh? Okay. So now let's look at this very term. So you use that very definition. So I have to put in. So integral d3 of x, and this thing what you get? Dirac delta function. So it is delta 3 p minus p prime. Clear? Now what about the integral on this thing?
0.
So it gives you 0 because both are stars. समझ आवा? Okay. So now integrate over, so what you get here, so you get simply d3p delta 3 p minus p prime, okay, a of p. So what you get? So integrate over p, p will be replaced by AP prime. So y prime, so you have an index prime here, is it? On left hand side you are having a prime, P prime, and on the right hand side you get P prime. Clear? Or in other words, I will write this A of P in terms of this phi as D3 of x, FP of x star, I partial 0, phi of x. Clear? So this is A of P. Now A dagger P is actually the conjugate to this object. Clear? You got my point? A dagger is okay. So let's calculate A dagger from there. Eh? So let's calculate A dagger. Now what I need to do? If I need to figure A dagger, what I need to put? Instead of FP star, I will write simply F. Clear? So for A dagger, I need to put F. So it will be F. So what it will be? F. Clear? So this term will become 0 and this term will become delta 3 P minus P. And you integrate over now P, what you will get? You integrate over P, you will get A dagger of P prime, and so that I can write, which implies this A dagger of P, that is equal to integral D3 of x, so that is simply FP of x I partial 0 phi of x. Okay, so now if you look at carefully this thing, these are conjugate to each other. Now let's take the conjugate of this thing, A dagger. Clear? So A dagger is this thing. So let's take these two are conjugate to each other. Let's take A dagger. So this will become what? F, only F. So I will become minus I. So it derivative will change actually. This phi will come here and this will go here. Okay, so let me show you. So it is something like this thing. Okay, F star partial 0 phi minus partial 0 F star phi. Clear? So now let's take its conjugate F dagger. So what you will get? So you will get this on this side, dagger, and F minus. So what you will get? Just tell me. So you will get phi dagger partial 0 F. But phi dagger is same as phi. So this is like this thing, minus phi partial 0 F. Since it is real, right? Phi dagger is same as phi. And there is an I, is it? So I forgot to put an I here. So there is an I. What I will become? So this I will become minus and this will become plus. Like this thing. Minus I. What you are? Just write this first. Okay? So if you see, just write this first. So it is phi I partial 0 F minus. Let me look at here. So there is an F star. Why it is F star? Huh? So there is no F star, huh? Yes, it's okay. So what you are having then? Just tell me. So it is the same as like this thing. F, this term, okay. So Fi partial 0 phi. Clear? So just check it. So it is the same thing as that very term. Huh? Yes, it's okay.
वो वापस आएगा फर्स्ट.
हाँ?
फर्स्ट टर्म में जब F पहले लिखेंगे तो वो टिल्डे आएगा. टिल्डे स्टार एंड डगर डगर कैंसिल F स्टार.
No, star will not be there. So you need to take actually the conjugate of each other. F is a function. Star and dagger for a function, it is same. So it is simply a function. It is not a matrix. This is also a function. It doesn't mean anything. Okay. So it will be same thing. Clear? Okay. So now let's calculate. The point is here. So you see these are conjugate to each other. Okay. So in this area extension, this A and A dagger are conjugate. That is why if they are not conjugate to each other, then phi is not real. Okay, look here. So this object is exactly conjugate of this thing. That makes phi to be real. Okay, and F. Okay. Is there any more thing? What makes phi to be real? That condition we have derived. A dagger P is equal to F minus P. Okay. So now let's calculate the commutator of A of P. This A of P, A dagger of P prime. So let's calculate this very commutator. We know the commutator of phi and pi, is it? Clear? Okay. So okay, so let's look at this very objective. Let's look at this thing. So it is integral d. Okay, so let me write it here. So it is something integral d3 of x. Let me write. Okay, fp star of x I partial 0 phi of x. Let me write. Okay, then you are having. Let me write integral d3 of x prime. Okay, fp. Sorry, p is also prime, and x is a dummy variable here. Okay, so it's like this thing. That's why you need to put prime in the fire. Okay, x prime. Okay, so just remember it. So let's take two integrals out. So you are having d3 of x, d3 of x prime. Okay, so let's evaluate this thing. So you are having two i's, is it? I and I, clear? So you take them out, what you get? Minus. I multiplied I is minus. Okay, so let's write this thing. So it is fp star of x. Then you are having partial 0 phi, clear? Is it? Is that true? Then you are having minus partial 0 fp star of x. Then you are having phi of x. Clear? And then you are having this very objective fp prime x prime partial 0 phi of x prime. Then minus partial 0 fp prime x prime. Okay? Then phi of x prime. Everybody got it? Everybody? Now what is partial 0 phi? It is phi dot. Okay, so this object is actually equal to phi dot of x. What that is equal to? That is the conjugate momentum pi of x. Clear? Similarly, this object is what? Phi dot of x prime. So that's equal to pi of x prime. So much now? So I am skipping many steps here. So now let's look at, it's a commutator. We know the commutator between phi and pi is 0. Pi and pi is 0. And there is only non-zero commutator between pi and pi. Clear? So that means, let's say, so you are having pi here, so pi here, it will be 0. You are having pi here and pi here, so that's non-zero. Clear? So let's write that. So you are having minus integral d3 of x, d3 of x prime. So let me write it as fp star of x. Okay, you are having pi here, pi of x. Then you are having commutator with this phi of x prime. Okay, so so let me take, since this is a function, it's a number, it will come out. So you are having simply minus, because you are having a minus here, so it will be partial 0 fp x prime and a commutator between pi of x, this pi of x, and there it is phi of x prime. So by the way, these are actually vectors. Okay, so you need to take, so you are having, this is all on the equal time, is it? So time is equal. So you can put a arrow here. So on equal time is clear. Okay, so these are the equal time commutators. Okay, minus. Now there will be, so this object and this object. So you are having this minus will come out. So then you are having this partial 0 fp star of x. Okay, then you are having fp prime of x prime, and then you are having a commutator between phi of x and phi of x prime. So let me put a vector here so that you will know these are all what? Equal time. Clear? So rest of the commutators are equal to 0. So what is the commutator here?
Minus.
So yes. So commutator between phi and pi is equal to I delta. Clear? But it is pi and phi. So it is equal to minus I delta 3 x minus x prime. So what it is here? I delta 3 x minus x prime. Clear? Okay. So now let's integrate over x prime. So let's integrate over x prime. What will happen to x prime? X prime will be replaced by x. Clear? So that means this x prime will be replaced by x. And similarly x prime will be replaced by x. You are having I in both cases. Okay, so you take I out. Okay, so this minus and minus, it will become plus. So you take minus out, it will become plus. So it will be something like d3 of x fp star of x. Okay, I. So it's minus I will write a minus here. Okay, let's put a minus outside. I partial 0 fp prime of x. Then you are having an I here. So I'll put a plus because this minus I have already taken out. So you are having partial 0 fp of x star, and then you are having fp prime x. Clear? So now if you see, it is simply d3 of x fp of, okay, something. Just tell me, fp star of x I partial 0 fp prime of x. So what is that equal to? That is simply equal to delta 3 p minus p prime. Just we have shown it. So that means A of p, A dagger of p is having this kind of commutation relation. Okay, so you are having A of p, okay, and A dagger of p prime. So that's simply equal to delta 3 p minus p prime. Clear? So show that this will be the home assignment for you people. A of p, okay, A of p prime. So that's equal to 0, okay, and A dagger of p, A dagger of p prime. So that's equal to 0. Clear? So it means, okay, so the quantization condition, okay, in terms of fields phi and pi, that is converted into a condition for A's, is it? So in other words, this condition is equivalent to the quantization condition. Clear? Samajh? And now we need to interpret what this A and A dagger are. Clear? For that matter, we need to calculate what is the Hamiltonian. Got it? Okay, so let's go to the Hamiltonian. So you should actually get an idea this A and A dagger should represent the annihilation and the creation operators. Clear? You should get an idea because it mimics what? Harmonic oscillator.
Yeah.
Does it mimic? So you had an harmonic oscillator in terms of x and p. Then once you write it in terms of A and A dagger, so what? So you start with a commutation relation xp is equal to IH task. Clear? Okay, then once you write it in terms of A and A dagger, what you get? A dagger is equal to identity. Is that the same thing? Is that the same thing? In the same line, along the same lines. Clear? Okay. So, but we'll get more. Okay, so it is better to understand first Hamiltonian. To get Hamiltonian in terms of these operators, then you can interpret them in a nice way. Okay, for that matter, so we need to figure out first what is the Hamiltonian. Okay. So, okay, so our Lagrangian is this. So let me write Hamiltonian that we have written yesterday. So this is our Hamiltonian. That means the d3 of x half of, okay, pi square of x plus gradient of phi square, okay, plus m square phi square of x. Okay. So now this is an operator. So this will be now the energy operator. So because these are operators. Okay. Clear? Got it? Are you getting it? Huh? Do you have any problem? Anybody having problem? I'm going a little bit fast today. Eh?
Yes,
sir. Okay, I know because these are trivial calculations. Eh? So I just want to give you the idea how to do the calculations. Okay. So let's take what's our phi of x. Okay, so let's calculate this very term first. Okay, then I will calculate this very term. This will be easier for you people. Okay, so what is our phi of x? d3 p divided by root of 2 pi cube twice EP. Then you are having A of p e raised power minus I p dot x plus a dagger p e raised for I p dot x. Clear? So now let's write this phi square of x and integrate over x. So this integration over this object. So let's calculate this very term. What is our phi square? Okay, so phi square means multiplying this object. So you are having d3 of x. So first term means phi square means, okay, so let me write this way. So you are having d3 of x, phi square of x, so that's equal to d3 of x, phi of x multiplied by phi of x. Clear? It's not dot, it is simply phi into phi. Clear? Okay, so let's write it. So it is d3p by root of 2 pi q twice ep a of p e raised for minus I p dot x plus a dagger p e raised for I p dot x. Okay, since p is a dummy variable, so you write it now here d3 p prime divided by root of 2 pi q twice ep prime. So then you are having this a of p prime e raised for minus I p prime dot x, okay, plus a dagger p prime e raised for I p prime dot x. Clear? So now let's multiply. Okay, so you need to multiply, but you need to take keep the order of, because a and a dagger, these are the operators. A comes first, then this a comes. You are having this a, then this a dagger. Clear? Keep track of the order of these operators. Okay. So what I will write. Okay, so let me do now a step directly. So you once you multiply, so what is the term you will get? You are having a of p and then a of p prime, is it? And what is the exponential? E raised for minus I p dot x, e raised for minus I. Okay, so let me write. Instead of wasting time this way, so it will be d3p prime, okay, divided by 2 pi q, okay, twice root of ep prime, okay, then you are having, okay, a of p prime e raised for minus I p plus p prime dot of x, okay, then you are having this a of p a dagger p prime e raised for minus I p minus p prime dot x. So this multiplied by this, you will be having p minus p prime. You take minus out actually. So you are having now a dagger of p, a of p prime, e raised for I p minus p prime dot x plus a dagger of p, a dagger of p prime, e raised for I p plus p prime dot x. So these are the terms. Okay, so now let's integrate over x first. Now integration is you are integrating over only the coordinate, not over time. Clear? So what you are having in this exponential, you are having both time as well as space. Clear? So let's look at those integrals. So you are this I have already done in a moment before this thing. So you are having like this p plus p prime dot x. So how I can write it as d3 of x e raised for minus I ep plus ep prime d, okay, minus, okay, p plus p prime dot x squared. Okay, so what is that? This will come out because there is no integration on this thing. So it's ep plus ep prime t, then you are having integration over d3 of x e raised for plus I p plus p prime dot of x. So this object is equal to 2 pi cube delta 3 p plus p prime. What is the argument here? Okay, so this very objective. So now when you multiply this thing with this thing, p is replaced by minus p prime. Okay, now this you are having ep is equal to root of p square plus m square. Clear? So what is ep prime? So ep prime will be p prime, but p prime is minus p. So that will be same as what? Let me write. So that is same as what? P square plus m square is equal to ep for, okay, p equal to minus p prime. Okay, even whether p is equal to p prime or so in both cases. So that means this very integral will be equal to simply 2 pi cube e raised for EP and EP are same minus I twice EP. The same is here. Now look here, the structure of this very objective. The same is here. You are having only plus here. There you are having minus. It's actually conjugate. It will be same thing. But this minus I will be replaced by plus I. Clear? Now let's look at this very thing. These two things. So you are having P minus P prime. What you had here? P plus P prime. So it means you will not get any exponential. So you are having here EP minus EP prime. That will be actually 0. It will be 1. Clear? So you, you need to put a delta function. P plus P prime. Clear? Okay. So you are having only, okay, so now let me write. So once you integrate over x, what you will get? D3P, okay, D3P prime divided by 2 pi cube twice root EP prime. So you are getting ARP prime, okay. 2 pi cube will cancel, so that I will not write. So it will be simply e raised for minus I twice EPT delta 3 P plus P prime, okay, plus ARP e diagram P prime, okay, sorry, it will be simply delta 3 P minus P prime here, now exponential, plus a diagram P ARP prime, okay, delta 3 P minus P prime, plus a diagram P, okay, a diagram P prime, okay, e raised for I twice EPT delta 3 P plus P prime. Clear? Okay, so now since this object is multiplying each term, so in this case it will not matter, but when we take this delta phi case, there will be a P, okay, so that matters, huh? That's why I will show you that very term. Okay, so now let's integrate over P, first term on over P prime. In the first term, okay, so everybody take a look, then you'll write. Look here, in the first term, when you integrate over P prime will be replaced by, P will be replaced by minus P. Minus P prime, or P prime will be replaced by minus P. Clear? And you are having this factor as well multiplying. For the first factor, it will be EP prime. Clear? So that will be simply EP. Got it? समझ आया? Because EP and EP prime will be same in both cases. Now look here. In this very case, when you integrate over P prime will be replaced by P. So let me put this very step down. Then you write. So it will be something like this thing. D3P divided by twice EP, because EP and EP prime will be same throughout, whether it is P equal to plus P or minus P. So it will be like this thing. ARP P prime will be in first term minus P, e raised for minus I twice EP T. In this very case, it is ARP A diagram P. In the next term, it is A diagram P ARP, and the last term will be A diagram P ARP minus P e raised for I twice EP. So call this some equation. Okay, so you can call this as equation 1. Let's call this as equation 2. Yes? No. Yes, there is an A diagram. Clear? Okay, so let's calculate quickly delta phi square. So right. Okay, everybody is written? So I'm a little bit, because I need to finish it, yeah? Hamilton and part. So I need to finish the interpretation of this thing. Then we can go to some more. Because these are trivial things. You have. Okay. Yes. So tomorrow maybe we can take them complex scalar field. Okay. Okay. So now let's calculate this delta phi. Maybe I require it. Okay, so let's calculate this delta phi. So what is delta phi? It means differentiation with respect to x. Clear? समझ आओ? So what you are having here? So let's write it. It is e raised for minus I ept minus p dot x. Clear? So what it is? E raised for I ept plus p dot x. Clear? So now let's take the differentiation with respect to x. This del phi of x. So what is that equal to? So it will be simply d3p divided by root of 2 pi cube twice ep. Okay, so now look here. So when you make a differentiation, okay, ap will be there, a of p will be there. So what you get? Differentiation with respect to x. So minus I, it's plus I, is it? So it will be plus ip. So what you'll get here, you'll get simply I vector p. It's not p, it's a vector p, because gradient is a vector quantity. Okay, समझ आओ? Okay. So then in the other case, what you'll get? So sorry, it is not plus here, it's minus. It's a minus here. Okay. In the other case, you'll get so e raised for minus I p dot x. You'll get minus I p. Okay. So a diagram p e raised for I p dot x. Clear? So समझ आओ? Okay. So now what is this object therefore? Integral d3 of x nebula phi square. So that is same as integral d3 of x nebula phi dot nebula phi. Clear? Because you are having a vector p, so you need to put a dot product p dot p. So that will give you the p square. Okay? Do the same thing. Okay, so this EP will remain as such. Clear? So what will change? Now tell me. So you are having I. Look here. You are having I. So I and I will be. Shall I write that step or I will put it here? Huh? So you are having I and I, that is minus I. Clear? So it is like this thing. d3 of x nebula pi square. So I and I is minus, so that will come here. And then you are having dp and then you will be having dp prime, is it? So two factors. So what you are having here, so in this case, you are having vector p here, then you are having p dot p actually. So you will be having p dot p prime. Like this thing, this will be plus, this will be minus, this will be minus, that will be plus. Clear? समझ आओ? Okay. So now everything is as usual. मतलब what we have done, everything is as. Is this clear? Look here. I have multiplied delta phi by delta phi. Clear? So what you will get? I into I will be minus. I square. That's minus. So minus I kept outside. Clear? So now you are having actually vector p multiplied by this and a minus a dagger. Clear? With the exponentials. So when you multiply, you are having a multiplied by a multiplied by a dagger. This comes with a minus sign, that's why you are having minus sign. Just need to multiplication. And you are having actually p here, is it? First integral will give you p, another integral give you p prime. Clear? So you put a p dot p prime. Clear? Okay, so now let's look at this thing. Since there is a delta function, so you have to multiply this p dot p prime to each term. Okay, because look here, why? You multiply, since this p dot p prime multiplies every term in this expansion. When you multiply, you will get a p. Okay, so let me put a p dot this way. So then maybe you can understand. P dot p prime. So what you are having? Minus p dot p prime. What you are having? Minus p dot p prime. So you are having plus p dot. So because there is a delta function which carries these signs. Okay, so let me erase this way. Okay. So now let's integrate over p prime in the first term. So integrate over. EP will be same as EP prime, so that doesn't make difference. So it will be simply twice EP here. So in this case, when p you integrate over p prime will be replaced by minus p. So it will be minus p. It will be minus p. So it's minus p square. A p minus p e raised for minus I twice EP t. So here P prime will be replaced by P. It is simply minus P square A of P E diagram P. Okay. In the next term, it is same as P square A diagram P. Okay. A of P. In the last term, you are having minus P square. Why? P prime is minus P. So A diagram P. A diagram minus P e raised to I twice E P T. Now look here, in the very first case you are having the terms with exponential and the terms without any exponential. Okay. So once you calculate pi square, pi is what? It's phi dot, is it? When you calculate pi is equal to that is phi dot square, you will be getting the same way. You will be getting actually EP, AP, A of minus P exponential of this thing. Then you have to club the terms. Okay? And use the, okay, once you club the terms, so this will be from here, it will be the home assignment. Okay? Use this relation, E square minus P square equal to M square, or the variation of this thing. Okay, okay, I will give the hint. Okay, now look here. In the last term, you are having M square, is it? So in this very term, you are getting P square, is it? In this very term, you will get E square. What is E square minus P square plus M square? Sorry, minus M square. So that will be equal to 0. So since there is a minus, I'm sorry, we are forgetting this minus. Minus, so this will be plus. This will be
plus.
Yes, every term will be plus. Clear? समझ आवा? Because of that minus. Now look here. So in this very term, you will get E square. समझ आवा? What you have got? P square. In the last term, what you are getting? M square. So you have to make sure E square minus P square is equal to M square. समझ आवा? So those will cancel those terms. These terms will cancel out. These will remain. So you will be getting simply 1 in these very terms. Rather simply EP square you will get. Okay? So this term and this term will sustain. So these will cancel out. Clear? So ultimately what you will get, so you will get H is equal to integral D3P, okay, EP divided by 2, okay, A diagram P, A of P plus A of P, A diagram. So this is the Hamiltonian. So now you can, so this is the Hamiltonian in terms of what? A and A diagrams. Okay? Got it? So you have to work out those steps. Huh? So those are very trivial. So just work out. Okay, so I will. Okay, so let me make some now interpretation of these A's. So that will end our lecture, today's lecture. Okay. So now let's go to harmonic oscillator first. Okay. So what is the Hamiltonian of harmonic oscillator? So that is equal to H cross omega A dagger A plus A dagger. So once you use A dagger is equal to 1, so you put it as A dagger A plus half, is it? So समझ में? Okay, so divide by 2. So now if I write now this H and A dagger, so what it gives me? H cross omega A dagger. So if I write H and A, so what it gives me? Minus H cross omega A. So if the Hamiltonian with this operator gives you this kind of object, it means A dagger creates a state. Okay? समझ में? Or A dagger creates a quantum of H cross omega. Clear? Okay, so like this thing. Let's start from some state, some zeroth state. So you are, let's say you are having some nth state. Okay, so you can create from this A dagger a quantum of how much? So H cross omega. So it will be simply n plus 1. With this A, you are doing what? Minus H cross omega. Okay, so you will get n minus 1 state. So in other words, in the harmonic oscillator, you can interpret this A dagger and A as the annihilation, okay, creation and the annihilation operators respectively. Clear? So this is how we interpret. Now similarly, if I, okay, so if you see, so you have, okay, so look at the structure of the Hamiltonian. We started with a field, is it? Clear? Now look at the structure of the Hamiltonian. You are having same as A dagger, A dagger. Clear? For, okay, forget about this integration for the time being. EP is the energy of the particle. Clear? How much is energy? It is relativistic energy. P square plus m. Sorry, P square plus m square. Clear? Root of P square plus m square. So that is the energy. What is the energy there? H plus omega by 2. H plus omega, and here it is EP. Clear? Forget about this 2. Forget about this integration. So you can say this is simply a harmonic oscillator. So that means for every momentum what you are having, for every momentum you are having a harmonic oscillator. So P is a momentum, clear? So and momentum goes from 0 to infinity, let's say, or minus infinity to plus infinity. Okay, so that means you have so you have reduced actually your field as a system of harmonic oscillators.
Continuous system.
Okay, so it is actually now you can think this. This once you quantize a field, let's say here we have quantized the scalar field, so you can think in terms of the harmonic oscillators, okay, and infinite number of harmonic oscillators because there is an integration over momentum. Clear? So it is an infinite sum. So it contains an infinite number of harmonic oscillators. So what exactly these harmonic oscillators represent? So here, if you see, you are having a particle confined in a potential well, is it? In a parabolic potential, and you have in the small oscillation approximation, you say it's now your harmonic oscillator. Clear? Yes. So that means you are having a particle. It's simply this harmonic oscillator is a one particle. Clear? And here you can think it is a bunch. Okay, infinite number of particles. So that means that's why we say field represents your infinite number of particles. Clear? And those act as a harmonic oscillators. Okay. So now if I calculate this H and A, let's say A dagger, so what you get simply EP, A dagger, okay, and so I should put A of P like this thing, and similarly if you take H A of P, so you get minus EP. So that means the interpretation of this A and A dagger are same as annihilation at the creation operators. So look here. Here you are moving from one state to another state. You are not creating a particle, by the way. You are just adding a state. So you are moving from state n to n plus 1. It is for the one particle, its energy levels are there, and you move from one state to the another state with the help of A or A dagger. But here what you are doing, you are actually adding a particle to this momentum state P, because these are the free particles. Okay, we started with a free field. Clear? So these are the free particles. So it means A dagger will add a particle to the momentum state P, or A will annihilate a particle in the momentum state P. Clear? So here let's say you are having let's assume your free particle state is P. Clear? A momentum state. P will specify here, you can think P as a quantum number. Clear? You can add a state to it, or you can remove you can add a particle to it, or you can remove a particle from it. Okay, so those are particle annihilation and creation operators, and there is a fundamental difference between the two. These are not the particle, and to say you don't add or create a particle here, you just shift states. That's why these are known as ladder operators more appropriately. Okay, clear? So we'll take tomorrow from this very point. Okay, so let's define the vacuum of the field. Okay, so we need to define the vacuum, the ground state. Okay, so how I define now the vacuum state? I should say the ground state of our system. So we define it by A of P. So let's write this as the ground state. It is equal to 0. So your vacuum is annihilated by A of P. Clear? So A of P annihilates the vacuum. So what you should expect? What is the energy of the vacuum?
0.
So when I am taking the free particle and I am considering only the positive energies, is it? So what you should you should get the energy. So you start counting energy from 0. Clear? It's a natural choice. So for a free particle, you start from the 0 and you move away. Now let's look at that very thing. This edge. Okay, so let's rewrite this edge. There is occurring a problem. So So let's rewrite this thing. So I can write this d3p, okay, divided by 2 EP. So I can write it as A dagger of P, A of P, okay. So now I will use a commutation relation. Okay, so let's write the commutation relation for this A dagger. So I can write it as simply A dagger of P, A of P. Okay, so I will use this commutation A of P, okay, A dagger P prime. So that's equal to delta 3 P minus P. So now P and P is same, P and P prime is same, correct? So you can write A dagger as A dagger A plus the delta function, is it? Okay, so I will write as A dagger A plus the delta function. So what is delta function? Delta 3 P minus P, that is 0. So let me put a small p here. So to remember, to mention that it's a delta function in momentum space. Clear? Got it? So what you are getting? So it is twice and 2 goes. So you are having this d3p EP. So it's A dagger P, okay, A of P plus this objective d3p EP delta 3 0p. Okay. So there is no argument here. That it is an infinite quantity. Clear? So and you are integrating over the entire space here. I mean all the possible values of the momentum. So it means it is an infinite quantity. Okay. So now let's calculate the energy of this very state. Okay. So I will write now H acting on this 0. So what you will get? D3P EP A dagger P A of P, okay, acting on this 0 plus this infinite constant. Let me write this as IC acting on this 0. Clear? So let's call this as IC. Okay, so instead of IC, let's put the integral d3p EP delta 3 0 P acting on 0. So what is A will annihilate this vacuum, is it?
Yes.
So that means what you get? You get actually an infinity. Because this will be 0. This is what? An infinite quantity. Clear? Is it true? So that means this. So the ground state is having what? Infinite, energy. Okay, so what does it mean? Okay, so let's explain it this way first. Then I will tell you what exactly, how to remove this thing. What is, what are its constants? Look here, we have just shown here. So we can reduce the field to be the bunch of harmonic oscillators, or the infinite number of harmonic oscillators, is it? So let's go to the harmonic oscillator itself. So you can write a harmonic oscillator H cross omega A dagger A plus half, is it? So this is the energy. Sorry, H. And what so what is the ground state energy? 1 by 2. So what we call that? 0 point energy. And you are not measuring 0 point energy. You are measuring actually the energy difference between the levels. So you are measuring, like say you are having here H cross by 2. You are actually measuring this very difference. So that's always H cross omega. Clear? So now if you add, so let's say if you are having a system of n harmonic oscillator, n harmonic oscillators will contribute this 0 point energy. Is it? So each will contribute H cross omega by half H cross omega. Okay. So now if you are having infinite number of oscillators, what will happen? So you'll get infinite number. Okay. So that's exactly what is happening here. So you are getting this thing. So we call it as a vacuum energy. Okay. But what is in the physical world? What we do? We don't measure. So you can say the vacuum possesses your infinite energy. Okay. So this is an infinite amount of quantity, but it is not a measurable quantity. So what is in reality what we do? We measure not the absolute energies, we measure the energy difference. We can measure the energy between two levels. Let's say ground state at the first level. Clear? So we don't measure when we measure the energy of the ground state of hydrogen atom, what we do? We actually measure it with respect to the nuclear potential. Clear? Samajh? So that's why it is 13.6 eV. Clear? So because we define it with respect to vacuum defined by the nucleus. Okay, a certain kind of vacuum. Clear? So you always define the energy. When you measure the energies, you measure the energy differences. Okay, so that is actually the physical quantity. But how to get rid of this very infinite constant? Clear? So what I will do, so it is something, let's say you are measuring the height of a building. You can go to another building and measure the height of the building. You will get the same number if you are measuring from the bottom of the building. Clear? Is it true? So it is independent of the choice of the reference frame. I mean, where you are measuring, you will get ultimately the same height of the building. Clear? So that only the difference matters. Wherever you are, only the difference matters. What we will do, so there is a procedure to remove this infinite. Okay, so what I will do, so I will instead reorient my coordinate system, you can think, and let's say my ground state is defined at the zero energy. Clear? So let's redefine my ground state in such a way its energy is what? Zero, and make it the energy with respect to the ground state. So there is a procedure of doing that we call it as a normal ordering. Normal ordering of operators. Okay, so normal ordering means if you are having a string of these operators containing annihilation and the creation operators, you put all the annihilation operators to the right of the creation operators. Understand what I mean? So put all annihilation operators to the right of creation operators. So we are almost done. So what does that mean? So let's take a look here. So let's take, we'll do define it. So we are having this very thing. So D3P by 2 EP. Okay. So in other words, you are actually putting, okay, so you are removing this infinite number. So in this way. Okay, so let's take this thing. So if I do the normal ordering, what I mean to say, so you put these epsilon, so what we call them? Ellipses, So these are ellipses, You know it?
No, sir.
So we put it, this means it's a normal order. Okay, so what I mean by that, so I need to normal order the, so if these are the bosonic, so it means I have to do A dagger P. So this object I have to normal order, plus I have to normal order this very object. What I mean by normal ordering? Putting all the annihilation towards the to the right of the creation operator. Now annihilation is already towards what? Right of the creation operator. So it is as okay. So there is no problem with this thing. Okay? So it is same as A dagger P, A of P. So what is the normal ordering here? So you put A of P here, clear? So since they are okay, so I will tell you so why not a sign change? Okay, so it's like this thing. Normal ordering means so you are having this commutator because ultimately you are using this very commutator, clear? So A dagger, you are using it in terms of A dagger A, clear? So where from the infinite constant comes? From this delta function, clear? So simply when I normal order this object, so it means you have to put this as 0. So you say same as A dagger is same as A dagger A, clear? Okay. Samajh aaya? Okay. So now you got it? Everybody got it? Okay, so now what you are getting here? So D3P EP A dagger P A. Clear? Samajh aaya? So it is a harmonic. Okay, so this is one harmonic oscillator with energy EP, clear? And you sum them. So now let's check the energy of the vacuum, this ground state. Okay, so therefore I can write this H acting on 0. So what you get? D3P. So EP A dagger of P A of P acting on 0. So what you get? 0. So now the infinite constant is removed. What I have done, we have just done what? We have ignored the infinite constant, clear? So which is contributing to the vacuum. We have just said So you are measuring now energy with respect to the vacuum. That, yeah.
So it means by normal ordering,
Yeah.
the operator changed to the normal variables.
Really not.
How can it be zero?
Huh? No. What we are doing, we are simply removing this infinite constant. I mean, in our calculation, it is a consistent procedure. I mean to say, wherever you find a operator, so because of this very commutation, what you are getting, you will get always an infinite constant. So you are only removing the infinite constant, but the nature of the operators remains same. They are not the variables. Okay. So it's actually you have measured energy difference. Okay. Got it? So it's not like that. So why I have put this very example? Because one is in the fermions. So when you do the normal ordering, so that will be replaced by minus with a negative sign instead of the plus sign. You got it? Okay. So now let's check what is the energy now. So is the energy really positive? Because we have to also check it. So let's check the energy of the state, energy of the ground state. Let's say so 0. So that is already 0. Clear? So okay. So let's write the energy of some state. So let's write some momentum P and P prime. So what that is? D3P. So EP P, A diagram P, A of P, P. Clear? So let's write energy. So this will be the expectation. Is this expectation value in a moment in some state P? Clear? So what I can write it, since this object is the conjugate of this thing, so I will write it as D3P EP mod of AFP acting on P square. Since magnitude of any quantity, square magnitude is a positive quantity, EP is already positive. Okay, so that means this is what. So now you see for any state P, the energy is positive. So negative energy are now removed. Clear? Got it? So this finishes our real scalar theory. We'll be going to the complex scalar theory in the next lecture. Okay?